First of all, thanks for joining for today's demo, everyone. And my name is Srinivas, and I have nearly 20 plus years of experience. And I come up with a combination of data engineering and data science. I'm currently working as a cloud data architect in a multinational bank in UK, and I do work on data science solutions as well. On top of this, but majorly I use Snowflake, DBT, AWS Airflow, and some part of Snowpark also I am currently using. So today's agenda basically is to give a high level overview on Snowflake and how Snowflake is different from other particular cloud data warehouses or databases, and how why companies are specifically looking for Snowflake, and how Snowflake is unique in the market. What are the other different features which are making Snowflake top in the cloud data warehouses? And we also will see some part of differences between other clouds and how Snowflake is compared to them, how Snowflake is unique. Plus also I'll try to show you how to create a Snowflake account, and where you can go and log in and see the interface and try to see some basic commands. That's what I'm just planning. So let us try to see that. I'm sharing my screen. Let me know you're able to see. Everyone. Hope you're able to see my screen, everyone. Is it visible?
Yes, Sri. We can see
Okay.
it.
Okay, nice. So when I talk about Snowflake, right? Snowflake is, as we know, like Snowflake is a cloud data warehouse. But first of all, when I talk about data warehouse, the conventional data warehouse, right, which is already available, that was basically was not initially available, right? People use it to leverage databases to store the data. You see, in 90s decade, most of the companies were very busy in centralizing their data into the RDBMS databases, where Oracle SQL Server and then Sybase, Postgres, MySQL, most of these databases are became very popular in the market, and every company at enterprise level they started building their own databases and started leveraging them as a backend for their applications and further like developments and activities. So whenever the company started thinking like how to analyze the data, the actual challenge came into the picture, because most of the real-time data will not be stable, which will be most frequently changing. So companies started thinking on how to leverage this particular data to analysis. So they were having some challenges to analyze, because when the data keeps on changing, your analysis also will be going in a wrong direction. So that is where the birth of data warehouse came into picture, because the data warehouse, which the conventional data warehouse was born in early 2000s, where every company started centralizing their data, which is in the real time, and separating them into a other database with all historical data, and they started calling that as a data warehouse. Just a minute. So data changing in the sense like the real-time data, for example, the customer address may change, right? Anytime. For example, I'm using the customer details for analysis. The customer transactional data also may change. The transaction amount may change. If I'm using that particular customer transaction in my for example, I want to see what is the transaction amount the customer may withdraw. So if suddenly it may change. If it changes, I cannot go and do my analysis or dashboard, and I cannot go and even confirm most of the times. So these particular changes will impact most of the like analytics. So if I have a separate data warehouse, we can use only for the dashboard development, and we can leverage it for the analytics also, like machine learning and other kind of data also. We can go and leverage and build that. But as soon as if you see, most of the data warehouses which were built during that time period, the sources were majorly RDBMS like Oracle SQL Server and CSV files, and most of the data is structured here. No semi-structured, unstructured, and quasi-structured data was there. And the tools like Informatica, Data Stage, and SSIS, this particular tools became very popular to implement the ETL pipelines, and every company started building their enterprise level data warehouses using these tools. Plus, as soon as data is available in the data warehouse, the tools like Crystal Reports and Business Objects, MicroStrategy, all these tools became the reporting tools for generating the business intelligence and dashboards. And coming to the sources for this particular data, also companies' internal products and CRM applications, most of the data is the internal company's data. And also the type of structure of the data is only structured, no other types of formats were there that time. And whoever wants to work on this particular conventional data warehouse, they should know specifically Oracle, like SQL and PLSQL, if they are dealing with Oracle database. If they are using SQL Server, people used to leverage TSQL and other like SQL databases. And coming to like data loading frequency, if you see, there was mainly batch data loading where companies to wait for the end of day for business transactions, and they used to have a batch group of batch jobs which will try to refresh the enterprise level data warehouse with the real time database. So most of the companies were following the same approach. And after the data has been centralized, there were products which companies to develop like revenue leakage fixing and potential customers like identification who are ready to churn. These kind of applications people use it to build at very high level. There was even no data science also that time because of the initial stages of data warehouse. But as soon as we moved to the 2010 decade, there was a big revolution in the data. Correct, no? So most of the companies or industry experienced suddenly high data growth. What could be the reason? Can someone answer that? Why there was sudden data growth happened after 2010? What was the reason that time? Anyone? Any answer will be okay. This is not like 100%, should not be 100% correct. So whatever you know, what could be the reason for sudden data growth in after 2010? Any idea? Anyone?
The number of users
Number of
on the
users.
number of, yeah,
Um,
you who are accessing the application,
Correct. Agree.
different kind of
The user
application.
consumption increased. Why it is increased? Because social media came into picture. Correct, no?
Yeah,
So the social media was one of the biggest reason, right? Why this sudden data growth happened. And most of the social media companies like where Facebook started their services, and suddenly they offered the users to upload like videos, documents, images, and the consumption, the utilization of Facebook became very high that time. Since this Facebook got a success, we got other social media applications also. Like we got like YouTube, we got like WhatsApp, Instagram, Twitter, LinkedIn. Many different applications have been implemented, and they started generating data. Telegram, so many different applications. So suddenly the data growth increased. So since most of the data is unstructured here, we can't store in the databases. So the company started thinking for alternative solution, that is where big data came to the market. So big data tools like Hadoop and majorly HDFS plus MapReduce. These two frameworks became very popular to maintain the big data, and the MapReduce was a little bit tricky because we used to write the code. Most of the companies looking for developers who know to write, do the development in Java, and who knows how to process the large amount of data which is on top of HDFS, and most of the data is in files, and the HDFS Hadoop distributed file system is to store it, and MapReduce is to process it. But MapReduce was having some limitations to process this data, which is where it is to take hours and hours to process with bad jobs. Spark came to the market and slowly replaced MapReduce with the in-memory computing features. And this big data warehouses which companies built slowly converted to big data lakes also. Because when I worked with MasterCard also, I started building a conventional data warehouse and then migrated to big data warehouse and then to big data lake, because the industry is moving towards real-time data processing also. For example, when you want to process real-time transactions, we need to capture the real-time data also, like credit card fraud transactions. So if I want to mark or block the fraud transactions on a credit card, I should be able to capture the real-time transactions of the credit card. If you want to recommend something to the customer, I should be able to manage or process their real-time activities. Amazon or other e-commerce companies, they do this kind of real-time data recommendations. They provide some recommendations, right? When you go to Amazon, we receive some recommendations on fly. Correct or not, everyone? When you buy some product, before you are going to pay the money, they will recommend you few other products also, right? So the recommendation algorithm will run in the background with the actions that you perform. So which pages you visited, which products you selected, and what products you selected and added to the cart, and they will try to see, they will keep on monitoring your activities. If suddenly there is a reduce in the price, they will notify. Correct or not, everyone? They will send an email, right? There is a reduction in the price of the products in your cart. You will receive an email. So why can't you buy these products together? So most companies, not only e-commerce, even many different domains, you see recommendation systems have been implemented. So
Okay, I have one question over here. Can I ask?
yeah. So
Okay.
it's good. Yeah.
Yeah, sorry to interrupt you. So just one question I have at this moment.
Mhm.
Since you are talking about the most of the companies started using because of unstructured data, so companies started using the different frameworks of the big data.
Mhm.
So my question is, right now in the current existing scenarios,
Mhm.
most of the company which is they are using NoSQL based database.
Correct.
It could be like the MongoDBs, and so other different applications are there.
Yeah.
And some company are also using it like a vector database.
Correct.
So the question is what is a real architecture level difference between the big data frameworks between NoSQLs and the vector database?
See, vector databases and NoSQL databases, all majorly we have different NoSQL databases already. We have key value pair, for example, where they will store the data in the form of JSON format. So we have different types of storage which they follow.
Mm-hmm.
But vector database, I'm not 100% sure. Sorry for that. But coming to like big data side, most of the data, even in HBase also, you will see the data will be stored in a not like a structured form, right? They use a column family. Even if you go to like for example DynamoDB also, you will see like the data will be stored in the form of key value pair. So why they will store the data in the form of key value pair is the data retrieval will be faster. So that is what majorly that is only suitable for the even large amount of like a big data kind of applications. But it is a data which is a structured form. We do not even need to go for big data. So even big data means not like a small amount of data, right? So big data means you should have a petabytes of data. So that is the reason most of the cloud services also started building their own databases for this particular maintenance. Like for example, Redshift is a structured data only, but petabytes of data I can store. If my
Okay,
data
so
is,
the okay, so like if you say that is the key value pair is only like the important structure to store the data, to retrieval the data is faster. But let's say if I talk about like like in MongoDBs, so here the data is getting stored in the form of document, right?
correct,
And
correct,
those are also in the key values pair, right?
correct.
So the question is like, if you keep like, any object in the storage, if you keep any object into the storage kind of, data types, okay. So it is the only purpose that is the data retrieval is faster, or can we store more data and because of that we started using big data?
See, big data means not only storage, right? You should be able to even like you should have a high velocity in retrieving data. You also need to store with the same high data ingestion speed should be there. See, big data means not only like only volume, right? We also need to see
Right,
how fast you are
right.
loading, how fast you are retrieving, also important. And
Yeah, I understand. But then
normal
why we
database.
have a difference like between big data and like NoSQL structure? Because if I talk about, so both are having a like unstructured data, right? Both are
Correct.
getting stored the unstructured data. And when you talk about big data, you say that is there is a like the fast retrieval of data and data processing is
Correct.
very high, right?
Correct.
And it is only because of that we use big data, or is there any something else between big data versus NoSQL data?
See, NoSQL databases are some part of big data. So there are other databases also. So not only NoSQL, even if you go and see, Redshift is not like a NoSQL database, right? Correct or not? So that is also structured database. We can manage petabytes of data. See, I'm not saying only NoSQL database only can store the big data and all. There are like structured databases also available now. So see, the industry is changing towards like cloud databases because Snowflake is also internally it will store in the form of micro partitions. I'll discuss about that because I want to show the difference because uh, how Snowflake is going to store in the background also. Like when you retrieve the data, you can retrieve in a structured, semi-structured form, but internally it will store how it stores in the data also in the form of files only, micro partitions. So there are so many differences here. Yeah, I'm just giving an example like how the data was traveled and then how Snowflake is going to like become one of the leader in the data warehousing side. So that's what I'm going to discuss. Okay.
Okay.
Let us move.
Thank
Let us move. Yeah.
you. Okay. Thank
Let me add something to that.
Mhm.
Yeah, so when we are dealing with non-SQL databases, so mainly we do not have transformation supply over there because you have only the
Correct.
data.
First we load the
But
data and then later
you
we
need
will
to
apply.
apply. Yeah, you need to then you need to visualize those things, or you need to get some insights from your data. So
Correct.
that traditional non-SQL databases won't support. So then in that case, we need to jump into these big data technologies.
See,
Okay, but
data volume is
okay.
high, right? So I cannot apply the transformations on fly. So that is the reason the ETL has been changed to ELT also.
Right. So that is what my question is like, because ETL has been, it is up to you. You have to transform it or not, because you can do either you can just extract and load,
Yeah, the
or
basic
maybe later on
difference
you can transform,
is
right?
that only.
Yeah.
And you asked that vector DB, right?
Right.
So in vector DB, the data is stored in the numeric. Suppose
No, I understand. I understand what is meaning of vector database, because it is going to
Yeah.
convert your, like, non-structured data, maybe like, text data in the form of, vector. And
Yeah.
in between the vector, it is trying to convert, it is trying to capture the, like, semantically meaning of those, text values, right? I understand those
it
ones.
will fetch a semantic, which
Yeah,
is nearest.
it is semantic values based upon like, cosine and factors. But
Yeah.
understand it like, when you talk about ELT structures, so it is up to us, like, we should able to transform it or not, because it is not always required. That is because of ETL architecture and ELT architectures, we have to use like, from NoSQL to big data. It is not like that, which is I disagree on that.
Rohit, let us move because this
Yeah.
context is about Snowflake, so we have enough short time. Okay, we will see that maybe offline. Okay, Rohit.
Sure. Thank you. Yeah, please.
Yeah. So when we talk about like this big data warehouse, and big data lakes, there are some challenges in maintaining these particular big data warehouses also, and data where the companies has to spend more uh, uh, like infrastructure they have to go and buy, and also to maintain they have separate dedicated teams. So this is one of the like a challenge for even for developers to learn these many frameworks where big data when it got emerged, we got so many frameworks. So to migrate existing data warehousing technologies to big data also is not easy. So every company when they started their big data and like in the enterprise environments also, initially there were no challenges, but when they move forward, the challenges became like very high because maintenance is very hard, because people when they want to go and maintain this particular big data environment, they need a dedicated Hadoop administrators who knows Linux administration, and even if you want to hire them, they need to pay very high salaries, and need to hire a separate dedicated team to maintain these big data clusters. So because the cost and also like also even the processing speed also very high, the maintenance were very hard, and sometimes you also need to have a like a dedicated like a team who is responsible for like resolving issues and all, and security, even security was there. People used to like look for some Kerberos and other security features, and the main challenge was how to maintain that, and how to like hire the people who knows multiple technologies and frameworks. So when we move to the like Snowflake data warehouse, the Snowflake is basically a SQL database, and some part of Python also you can use to maintain the Snowflake environment. And big data is basically if at all you want to maintain, you need to go and should know like Java, Scala, or Python kind of languages. And supported formats, if you see in the big data side, it supports both structured, semi-structured, and all like even unstructured data also. But Snowflake initially it was not supporting the unstructured data. Now they are supporting even unstructured data also, including semi-structured and structured data. And we can directly go and query the semi-structured data in Snowflake by leveraging the select statement. And but in case of like big data and other frameworks, we need to like convert them into structured, and we need to go and select that. And live data streaming we can do with the Kafka connector in Snowflake. At the same time, Kafka is a framework which is a like a streaming framework for live data we can use even in big data side. And the product stability, if you see in big data side, it is fragile because the ecosystem will be keep on changing, and new releases will be available every time, and we need to upgrade, and then we need to have a separate maintenance for that. But in case of Snowflake, everything is fully integrated with one single product. So because Snowflake is a SaaS, so all the patching, upgrading, provisioning, everything will be done by Snowflake team in the background. We do not need to perform any like kind of patching and upgrading. But in case of big data side, we need to have a separate DevOps team who will take care of this particular patching and upgrading. And performance optimization, we need a manual intervention in big data side. And in Snowflake side, we do not need to like do it 100% because most of the uh, performance optimization will be done in built, and it will be done by the team. If at application level, if you want to do some optimization, we can use clustering and micro partitioning at query level and data retrieval level. And the data transformation, if you see in the big data side, we need to write our own like PySpark scripts or other kind of like transformation scripts. But in case of Snowflake, we already have the GI tools available like Matillion, DBT, and stream sets. We also have CoolECTL, Fivetran. All these tools are helping to apply transformations on Snowflake data directly. And supported side, if you see big data, anyway, it is by default now since cloud is available, so it is almost unlimited. And even Snowflake also allowing the customers to store the unlimited data. And the resource availability, as I mentioned, for big data side, you need we'll find very hard to find who knows those many frameworks and who knows to maintain the big data environment. The finding the people is not easy, but in case of Snowflake, because we can easily train people who knows SQL. You can simply go and train them on Snowflake and they can directly work on. And salaries also for both technologies are almost same if you go and see. But you need to, with a combination with not only Snowflake, we need to have like other tools knowledge like DBT, Airflow, and some part of Python or Snowpark. If you know, so you will be unique in the market. And coming to use cases side, big data is basically people use for majorly for real-time systems, but Snowflake can be used for both real-time and batch systems in most of the cases. And coming to like why Snowflake is unique in the market, because Snowflake is very simple and plug and play, where I can go and create my Snowflake account within 2 minutes and I can start using it. So I do not need to go and follow a big process of installing any software, and nothing is required, because since it's a product, you can simply register the account and create your credentials and log in and use it. And scalability side, I can scale up to any amount of data, any number of users, and any amount of workload. And if you go and see, Snowflake basically will use a feature called Snowflake virtual warehouses, which will be used for like providing resources to run the SQL statements in Snowflake. Each virtual warehouse is nothing but a compute. So that compute is nothing but a group of clusters, and this virtual warehouse in Snowflake will be having a separate size, like a t-shirt size, like small, small, medium, large, like that. So I can change the size of the virtual warehouse anytime. Normally in traditional databases, if I want to change, I need to stop the database server. Either you are increasing the storage or you are changing the compute. You definitely need to have a experience a downtime. But in Snowflake, we do not need to experience a downtime here. We can even change the warehouse size like when the queries are running. And then cost wise, if you see flexible cost here, because Snowflake follows a pay as you go, you do not need to pay any like upfront expenses, and you can use and you can pay. And also, like finally, the Snowflake is a one place for all your data, where you can centralize in one place. You can access from multiple devices and from multiple locations anytime. And this is making Snowflake unique in the market. And also, features wise, if you see, Snowflake have many different unique features. Like we have like data sharing, where we can share your data without physically transferring, with a feature called secure data sharing. And time travel and failsafe, which will automatically back up your data and up to maximum 3 months with time travel. Even after time travel will expired, we can use failsafe period, which is up to 7 days. You can go and reach our Snowflake team to support to restore your data. And zero copy cloning, which is basically will help to create your backup without additional storage cost, because when you store the data in Snowflake, you need to pay storage cost. This zero copy cloning will try to eliminate your storage cost. And near zero maintenance. So the maintenance will be done by Snowflake team in the background. And caching is one of the feature which Snowflake offer the customers to store the query results and reduce the like Snowflake compute cost. So Snowflake will charge the customers in the form of credits. So these credits will be consumed whenever you run your SQL statements. So caching is going to eliminate using these credits by storing the query results in the cache. So query result cache, we'll discuss about that. And parallel computing also we can easily do in Snowflake by using the increasing the number of clusters in the warehouse, and where we can scale up and scale out. And automatic partitioning will be done, micro partitioning, which Snowflake will automatically divide your data into a group of micro partitions. And this data will be accessed with a normal select statement like rows and columns only. And all these features where Snowflake is becoming one of the unique cloud service provider. And there are other features also where you can go and use streams and tasks and dynamic tables and where you can go and plan your incremental loading by implementing ACD types. And also you can use Snowpark and Python, which can also automate most of your activities. And Snowflake also come up with many different unique features, new features we'll discuss in the upcoming classes. So like we have like a generate wave features, and we have like Snowflake intelligence, very new feature in the Snowflake environment. So Snowflake is trying to add all the features in single product so that a customer can utilize the end-to-end solutions inside Snowflake itself. Like you can also integrate with Git also. And the interface which Snowflake is as of now they are offering is no site. We'll see that. So let us try to create a free Snowflake account and see. So to create a Snowflake account, we need to go to Google and search for Snowflake free trial. There are options to create a Snowflake a 1 month account and a 4 months account also. So as of now, I'm just trying to show you a Snowflake free trial with 30 days. Like there is an option to create 120 days also, but I'm trying to show you as of now the 30 days account. We'll try to see the 120 days maybe in the next class. So here, this is the Snowflake sign up page where you will see as a user, you will receive $400 free credit. No need to add any credit card details, all which you need to worry. And just need to enter your details, and then you can mention the reason, any reason here, and then click on continue. And it will try to show you ask you the Snowflake your company name, and all you can give any name. And this particular edition, Snowflake edition, will be 4 types. We'll have Snowflake Standard Edition, Enterprise Edition, Business Critical, and Virtual Snowflake Virtual Private Edition. So Virtual Private Edition, if at all you want to register, you need to reach out Snowflake team. They will guide us. But Standard, Enterprise, Business Critical, these 3 editions have their own features. Standard is very basic level of edition with basic features. Enterprise will have all the standard features plus some additional features, where like we have 90 days time travel, multi-cluster warehouses which we can create, and material views we can create. So there are some additional extra features in the enterprise compared to standard. If you come to business critical, this is the additional, this is the addition which contains all the enterprise features, plus we'll have like additional data security and failover and failback features, where majorly the banks and financial institutions who are worried about data protection and security, they will go for business critical. So we can select any one edition here. So I'm just selecting enterprise as of now. And to host your Snowflake, you can select any one of these clouds here. So Snowflake is as of now offering like Azure, AWS, and GCP, only these three clouds. So when you are going to create your Snowflake account, your data usually will be maintained and your computer will be maintained in that particular cloud. So as of now, only these clouds Snowflake is offering. If your company is using AWS, try to use AWS here. Their companies already leveraging Azure, try to use Azure here. So I'm just selecting AWS as of now here, and then need to check this checkbox and click on get started. And it will show you some options here. You can skip them. And they will send an email notification to activate your account. You need to go to that particular account. Let us go there. So you would have received an email, activation email. So you can see here there is an activation email here. So every Snowflake new user will receive a URL like this. So this particular URL will indicate your unique account identifier. So this is your account identifier, and you need to keep this particular URL handy so that you can log in every time in the future. So I'm just clicking on click to activate, and this is going to redirect you to this Snowflake login page where you can go and create your username and password. I'm just trying to use my existing username and password. So let us click on get started. So this will go and redirect to the Snowsite web interface. So there was a classic interface earlier. Now Snowflake is not offering their almost like remove that classic interface. Now they are offering this customers to use this Snowsite web interface with many unique different features. So when you log in, you will see different tabs here with multiple like uses. So for example, I'll skip this particular option. Now you can see left hand side, you can see multiple different features here. Like you have a data ingestion tab where you can go and use to add some data and ingest some data directly with the interface, and a transformation tab where you can directly go and integrate with DBT, and also you can use dynamic tables and tasks here to schedule. And there is an interesting tab AI ML where you can go and implement most of the data science ML and generative solutions here, and without writing the code here. So monitoring is a tab for reviewing your query history and then service jobs, and there are some performance reviews we can do using Performance Explorer also. And marketplace is a tab where you will see the data will be available, where some free data will be available. If you want to leverage some free data sources and all, you can go to this particular applications, and you can like restore the data from them, and you can utilize that. And we also have catalog, which will have this database explorer where Snowflake will go and maintain your databases and all. And data sharing is the which I was talking about, which will basically will help you to share your data without physically transferring. So I can share my data with other Snowflake accounts also and non-Snowflake accounts also. So this feature will allow you to share your data with other Snowflake and non-Snowflake customers. And say like for example, governance and security will help you to manage your users and roles, and also your features like data masking, security like row level policies, row level masking and column level masking, object tagging, all you can implement here to maintain the data governance and security. And compute is basically where your warehouses will be maintained. As I was mentioning, the virtual warehouses. So these virtual warehouses are the fundamental backbone for most of the query execution here, SQL statement execution. So we need to have a better visibility on these warehouses, because this warehouse consumption will impact your billing also. So every warehouse or virtual warehouse, you call it as, is responsible for providing resources to run your SQL queries. So like CPU, memory, temporary storage, all will be provided by this virtual warehouse. So whatever that is currently running. So you need to optimally use this particular warehouse to manage your credits, and each credit will have some like billing, like $2 according to the Snowflake edition, it will change. So when you are consuming your credits means you are spending your money. So you should be very careful, and you should see whether is it really required, this particular warehouse of this size for my current SQL queries. We have different sizes here, we like X small, small, medium. So if your warehouse size increases, your query execution speed increases. But at the same time, you have to cross check whether you really require that much bigger warehouse, or is small warehouse enough for my data pipeline which I'm running. So this will comes on experience, and there are some best practices to understand on when to increase the warehouse size and when to decrease, and when to scale up and when to scale out, and which scaling paths you have to use. So all we have to understand. And we'll discuss about that when you go to the virtual warehouse module. And admin is the tab which will be visible to the administrators like account admin. And this will help you to review your cost and your accounts and your admin contacts, billing, everything here. And partner connect also, which will allow you to connect with other Snowflake partners like DBT, Matillion, ColisETL. There are so many partners here which Snowflake is offering. So you can see here where you can go and see business intelligence side. These are all the Snowflake partners, and we also have like a data integration side, many DBT, you can see ColisETL, Fivetran, and Informatica, like all like Matillion. You can also see like many different tools available here to integrate Snowflake and manage the Snowflake data from the tool. So majorly, so all these basically will help us to maintain this environment. And you see there are $400 free credit which we receive when you register your account, and that will be available up to 30 days. So in the 30 days, once you finish, this will be automatically redirected to the upgrade page. Or if you finish this $400 also, you need to upgrade your account. In both cases, you have to go and upgrade your account, and Snowflake will like prompt you to upgrade. And coming to like SQL commands, if I want to maintain my like SQL queries and all, I need to go to projects and go to the worksheets. So the worksheets are the SQL worksheets where you can go and run your SQL queries, and you can click on the plus here. And Snowflake is offering to customers to write their code in either SQL or Python directly here. So we have Python worksheets and SQL worksheets. So both you can use. So I'm just clicking on SQL worksheet, and here basically I can go and load the data directly from this interface also. For example, assume I want to create a new database where I can simply create either through command is one option to create database name. This is one option. I can simply run this. So it will create a database now. And every database, if you see here, every database will have two schemas by default, information schema and public. So this particular database which I created, this is from this particular command. But I can create a database using interface also. Where to create? I need to go to the database explorer here. If you go here, database explorer, this also can help us. So through interface also you can create. So here there is an option. You see here there is an option database here. If you click on this, this also will allow you. So I can create a database from here also, but it will only show you the database name. If at all I want to add any other like properties I need to set up for a database, I need to use a SQL command only. This can help only to create a simple database with name. Now every database will have some other properties also, so where you can add a time travel feature, and you can give some database retention period. So all these you can add through SQL command only. So particularly this database has been created. Assume that I want to load some data into some table into this database. I can use this public default schema, or I can get my own schema also. Maybe I'll just create a schema with name dev here, and which got created. Assume there are no any database objects here as of now. Assume I want to create a table here. So Snowflake is offering to create a table in different ways. Directly I can create from a file, or I can create through SQL command, or I can even create table as select. And there is an option to create directly from a external location files also. So let me first go with file. And here we can upload which file you want to load, and we can simply select browse here, and we can simply select which file you want to load. And for example, assume that I want to load some CSV file. So let us try to load it. So I have an employees file which contains 1000 rows. So let us try to load that. This file. So let us try to see on 8 columns. I think it contains. So I'll just give the name as. So it got loaded here, and I'll simply give some name here. And you can select which database and which schema also. You can change this if at all you want. As of now, I want to use the same demo and database and dev schema. And a schema is a collection of database objects. And I can even create a new database also if at all I want to create, because it is giving an option here. But I don't want to create a new database. I want to use a existing database, and now I want to create a new table also, because this table is not present. If you have any table already present with the same structure, we can even use it. But as of now, no table present. So I'm simply using this option as create new table, or else you can also use existing tables. They will be displayed here and you can use them. So simply click on the next button. And here it will automatically identify the type of file as CSV. And in CSV side, we also have TSV files, tab separated values, and pipe separated values also. So as of now, my file is comma separated, so it identified as comma by default. If you go and see, it will clearly say comma is the default one. So now my file is automatically like the schema also has been detected here. The first name, gender, start date, all this interface has been automatically identified, along with the data types also it is suggesting. If I want to change, you can change also. So now simply you can click on load, it will load the data, but internally how this is going to load the data is it will generate an SQL here. You can see a step by step. First is creating the table, and then it is creating some file format, and then using a copy into command to load. This we can also do that, but we need to understand what is data loading and what is the file format and what is the copy into all this stuff. So internally, even Snowflake interface also will do the same, but it will automatically generate this code. But I'll click on this particular load button, and you see that 1000 rows will be automatically loaded. See, and when you go and click on the table details, it will show us this is the data. So a CSV file we just loaded by leveraging this particular interface. I can even load JSON data, Parquet data. So if you click on this, it will clearly show what type of files we can load. Every file I can load, like JSON, ORC, Avro, Parquet, XML. I can load any kind of file, but I need to use this only up to 250 MB file size limit. If it is more than that, I cannot use this. Then I need to depend upon other alternative methods. I can even use Snowflake internal stages feature or external stages feature. So this is how you can go and need to load the data through interface. And I just want to show you as an example and how fast it is going to load also you might have seen. So even if it is a huge amount of data, Snowflake will try to load them within fraction of seconds, and we can leverage the warehouses here to achieve that. The warehouse size is important. The virtual warehouse size will determine how fast your data loading will happen or queries will be executed. We need to have a clarity on that, but we'll discuss about them anyway in the upcoming classes. But this is what I want to discuss today. At high level, I want to discuss about what is Snowflake and what are the different unique features and how to create a Snowflake account, free account, and how to do some kind of data loading using the interface. So that's what I want to discuss today, and I'll stop here. And any specific questions if you have, you can ask. Teja, Krishna, and Rishi.
Hi, hi sir. Actually, my question is,
Uh,
why to choose Snowflake's target of Databricks because both are similar
See,
and both are powerful.
exactly, very good question. So both have their own pros and cons, right? So Databricks also have its own features, but coming to Snowflake side, it has its own feature. Like Snowflake contains some features like time travel, fail safe, and it stores the data in the form of column oriented data, and it also have data sharing and data masking. See, that depends upon. If I go and see performance perspective, how to see. You cannot simply say Snowflake is better or database is better. You need to experience that, correct or not? Until unless you will not experience that, we can't say which is better. So in my experience, I saw like my data pipelines are which I prepared are running faster in Snowflake. So I'm experiencing that. So I'm saying Snowflake is better. So if you go and see in Databricks side also, there might be some scenarios where database is better. So both are competitors, correct? No, in the market. So everybody will try to say we are good. But when the scenario comes, then you will try to see which is better. So we need to experience that. So because I don't have much experience in Databricks platform, I used very limited time. But when I saw that time, I felt Snowflake is better because my data pipelines are running better compared to like Databricks, because I am using some machine learning features also. So I'm using some generative AI features and other features. So I use Snowflake with Snowpark. So I feel this is better. Okay.
So in your syllabus, Snowpark is also there, right?
Yes, it is there. Correct. Correct.
Okay. How is the Snowflake's market and how about the future of Snowflake's
See,
as well?
Snowflake is emerging, right? When I started my journey in Snowflake, I was doing most of things manually also. So now Snowflake is adding all different unique features like OpenFlow, which is like it is created. Snowflake added a feature for single data ingestion, and they added integrated DBT integration. They added Git integration. They added generative AI features. They added ML features. See, that is what everybody is looking for, right? Every company is looking for a single solution for all their enterprise level environment end to end. And also Snowflake contains many different connectors, right? So these connectors which will help you to easily manage the data by accessing Snowflake data from their environment, like different tools like DBT, Matillion, all these tools, majorly if you see, they were invented keeping Snowflake in mind. So most of the projects, if you see, they are already, some companies already migrated to Snowflake, and some projects are still in the process of migrating. But simply learning Snowflake is not going to help you, because we also need to know about how can we manage your end-to-end data pipelines using Snowflake, DBT, and Airflow is one of the popular orchestration tool which companies are using. And as per my experience, I see AWS was where was present when Snowflake was invented. So there are still some challenges in Azure side to integrate Snowflake. So AWS is one of the topmost cloud integration where companies are using. And along with that, we also have Snowpark, which is one unique feature which Snowflake is providing to eliminate some of the Snowflake cost by reducing the cost also. So we are going to learn all this in this particular course, one by one.
So Airflow is like
Hmm.
so the automation tool, right? Like Unix.
Orchestration tool, like
Okay.
where you can create, you can schedule the jobs with dependency, and in
Yeah,
my
like
case, huh, correct, you're
like
right.
Putty, like yeah,
Not like
job
Putty,
scheduler.
job scheduler, correct, correct. Earlier there was a tool called Uzi scheduler, Uzi scheduling framework.
No, no, we
In,
were working in cron jobs.
that's
It's
what I'm
also
telling.
scheduling, yeah,
That's what I'm
like
saying.
triggering. Yeah.
Yeah, we have control M desktop, we have Autosys, cron job, but all these have some challenges in the the licenses, and you need to buy license, and also you need to have some kind of like dependency, right? Job dependencies and all. But Airflow is a simple Python library which you can install and you can easily maintain. So everything is in Python. That's what you have to understand, everyone. So Python, if you know, you can manage anything. DBT is also Python library. Airflow is a Python library. Snowpark is a Python. Everything is Python. So Python is very important for market now. The Snowflake with Python is very popular now. If you manage your data pipelines with Snowflake with Python automation, I can show you an example which I built. Just give me a minute. Just because of the time constraint, I'm just waiting for whatever you see. whatever you see in my screen. I hope you are able to see my screen, right, everyone? I just reshared my screen.
It's loading.
Observe
Yeah,
here.
we can see.
Yeah, this particular interface, what you see here, this is my own interface which I written in Python, where I will simply give my Snowflake account and click on login. It will try to, just like a Snowset interface, I create my own interface where I can manage with my own customized environment, because not all the features we can experience in the Snowflake Snowset interface. So this particular tool, what I built, it will account level, we can go and log in by providing the URL, and I can manage the environment. It's taking some time. Maybe, yeah, we just logged in. So you can see in the left hand panel, there are different tabs available. So I can manage this particular tab like user and role management. So I'm just working on this particular interface to maintain my own like environment, where you will see like managing all the RBAC. So where I can go and see the rules, and I can create the users, create the rules. So I can see how many rules are present and all this analysis. And I can also enable multi-factor authentication, and I can do that and disable that. And this is user role management. And you can also see warehouse management, where I can manage my existing virtual warehouses. So you can go back and see this warehouse management and cost analysis. I can do, I can scale up and scale down the warehouses. I can resize them, and I can also go and like use database management also, how to create databases and how to select queries, and how to create tables and describe the tables. We can also perform all these activities. And we also have a intelligent Snowflake assistant also, where it will generate SQL statements using your text here.
So this all your own creation, or it is from Snowflake side?
No, I created on my own.
Oh, okay.
This is for my make my life easy. Okay.
Got it.
Yeah. This is a,
So at least this Ori will be explaining in this course, at least, because I'm very curious to know how you build this.
yeah. I will show you some examples like this. Okay. Are you getting?
Oh yeah, got it.
Okay, no problem. That's all for today. So because I need to jump to another call. Sorry guys. This will be continue from tomorrow, same 5 p.m. IST. And for more information, you can ping me in the WhatsApp. I'll guide you. I hope Rishi, you are part of the group, right? Or no?
Sorry,
And are you part of the community?
sorry, which community?
So how did you join this call? This part.
Yeah, I got a. I mean, I saw that message in the Snowflake's community.
Okay. Then you know my contact, right?
Yes, yes.
Okay, you can just ping me. Okay. So
Yeah,
everyone,
sure.
please
Thanks.
try to connect me, and I just pinged my number here. So you can ping me, and we can talk. Okay. Thank you so much.
Sure. Thank
Thank
you.
you so much. Yeah.
Thanks, Rick.
Guys, we'll just rejoin in 1 minute back, everyone.
Okay.
Yeah, please. Yeah.